sodium hydroxide that is in the laboratory. Apparently someone has made some sodium hydroxide and put it in a jar and did not label it, which is a terrible error. Terrible error in the chemistry lab. To find this out, she titrates 50 milliliters of sample of the solution with 3.5 molar hydrochloric acid. If it takes 34.3 mils of the hydrochloric to reach a titration endpoint, what is the concentration of sodium hydroxide? Well, let's see. What are we given here? We are given 50 mils. All right, so just to draw you a quick picture, here's your Erlenmeyer flask. Oh man, look at that. So in the Erlenmeyer flask, what did this chemist do? This laboratory assistant. They put 50 mils of HCl. Is that what they did? She titrates 50 mil sample. Oh no, she titrates 50 mil. She didn't put the HCl. Oh yeah, she put the NaOH in here. Right? She put NaOH in here. She put 50 mils of NaOH along with some phenolphthalein red, and she's going to titrate that. And she's going to titrate that with 3.5 molar hydrochloric acid. So here's the burette. Here's my burette that's not broken. Not a broken burette. Alright, and into that, she's going to use hydrochloric acid. And the hydrochloric acid, she knows the concentration of because whoever made the hydrochloric acid apparently labeled it. And it's 3.5 molar. 3.5 molar. And she's going to titrate that drop by drop into her Erlenmeyer flask until she gets a beautiful pink color. And you can't see my rotor there. There it is. Okay, there we go. Alright. So, she's going to titrate it with hydrochloric acid. The hydrochloric acid is 3.5 milliliters. She's titrating, and it turns a beautiful shade of pink. Oh, look at that. Oh, she did all my... Okay, it's broken. It doesn't work. Alright, anyway. They reach an end point, and she determines that it took exactly 34.3 mils of that hydrochloric acid to reach an end point. And what they want to know is what's the molarity of the NaOH that was left in the lab. What does that scream to you? Everybody should be screaming, mole-to-mole ratio, yeah, it's an acid-base titration, it's a neutralization reaction, a special case of double replacement action. And we know that in a neutralization reaction, we're always going to form what? Salt and water. So, what's the first thing we need to do? First thing we need to do is take a deep breath. Okay, we figured it out so far. We know what we need to do. Alright, so we're just going to do it. Very first thing is we're going to come up with an equation. What did they do? They reacted hydrochloric plus NaOH to form what? A salt. What's the salt going to be? Well, we know we're going to form water, right? Right? That's going to take this and this away. What's left? My sodium chloride, which is a salt. Plus H2O. Alright? That's our equation. Is it balanced? Yeah, it's balanced. 2 sodiums, 2 chlorides, 2 hydrogens, 1 oxygen. It's balanced. Sweet. Piece of cake. Alright. Alright, so now we're going to start with what they gave us. What did they give us? They gave us molarity, right? We know the hydrochloric is 3.5 molar. 3.5 molar kind of confuses you until you see that this is 3.5 moles per liter. And we also have this 34.3 3 milliliters, which incidentally is 0.034 liters. Whoops, I left off the 3. Just like a regular mole to mole when we used molar mass rather than molarity, we're going to start with what we're given. What were we given? We're going to need to change. We're going to have to change this hydrochloric that we know the molarity of and we know the amount of. We're going to have to change that into what? Sodium hydroxide. We're changing hydrochloric to sodium hydroxide. If we do that, it's got to be what? Mole to mole ratio. We're changing one thing from one thing into another. It's going to be a mole to mole ratio. So somehow we're going to have to get hydrochloric into moles. And once we get into moles, we're going to take it, use our balanced equation, and change it into sodium hydroxide. Magically. Well, let's start. What do we got? We've got 0.0343 liters of HCl. We know the molarity. The molarity is 1 liter of HCl is equal to 3.5 moles of HCl, right? We're using what we're given. They gave us this. We're plugging and chugging it down here so we can get our liters of HCl to cancel. Right? Now we're in moles of HCl. Oh, we made it into moles. Once we're in moles of HCl, we can do a mole to mole ratio. How many moles of HCl are there in moles of sodium hydroxide? All these numbers are 1. Right? So we know there's 1 mole of HCl in 1 mole of NaOH. Right? 1 mole of hydrochloric is equal to 1 mole of sodium hydroxide in this equation. All right, so 1 mole of NaOH. Oh, hey, wait, we're done. Oh, yeah, they just wanted molar mass, right? What do they want? Well, they just want a concentration. Oh, my gosh, they just want a concentration. Well, bless their hearts. They don't want grams. Okay, so we're done. Well, we're almost done. We're almost done. Almost done. Why are we almost done? Because we have it in moles. We're going to plug and chug this. And plug and chug ends up to be, did I do this? Yeah, I did this. Ends up to be 0.12 moles of NaOH. Woo! I hope that's right. I have my calculator. Right, so you multiply all this out, it comes out to be 0.12 moles of NaOH. Are we finished? No, because they want a concentration. They want molar. They want us to find out the molarity of this sodium hydroxide. Oh my gosh, how are we going to do that? In order to figure out molarity, we need a volume, right? We've got moles. This tells us moles, right? We got moles. What are we missing? We're missing liters. We're missing this. Are we? How many liters did this chemist use of the sodium hydroxide? It says she used 50 milliliters, right? We put 50 milliliters in here, so this becomes this number down here. But we have to put it in liters. So we've got 0.12 moles over 0.050 liters. And what's the molarity? 2.5, capital M, NaOH. No, yeah, NaOH. There it is. Oh man, that's easy. Piece of cake, right? Moles per liter of solution. We have 0.12 moles per 50 mils of solution. All right, so we're going to convert 50 mils to liters and just divide it out. What do you think? Any questions? No questions? Wow, excellent. All right, so that was number 9. Number 10 is pretty much the exact same thing. So let us move on to some new material. Woo, new material!